We have learned about the definition of the antiderivative and how to integrate by using a few techniques. So now we're going to do two applications of integrals. So a bicycle manufacturer estimates marginal revenue to be R prime of X is equal to 500 over the square root of X dollars per unit when the level of production is X units. The corresponding marginal cost has been found to be 0.8 X dollars per unit. Suppose the manufacturer's profit is 3,000 when the level of production is 9 units. What is the profit when the level of production is 20 units? So it's asking me, let's highlight what it's asking us. What is the profit when the level of production is 20 units? So let's write some of the things it gives us. So it gives us marginal revenue, which is the derivative of the revenue function. It gives us marginal cost, which is the derivative of the cost function. It tells me that the profit is 3,000 when the level of production is 9 units. So P of 9 is equal to 3,000. Why did I not write P prime? Because it doesn't tell me that marginal profit is 3,000. It tells me the original profit is 3,000. So that's not derivative, that's regular P. And then it's asking me, what is the profit when the production is 20? So when it's 20, what is the profit? Well, the only way I'm going to be able to plug in 20 into my profit function is if I have a profit function. So first, I need to find P of X. So I know that P of X is equal to R of X minus C of X, which is that the marginal profit is marginal revenue minus marginal cost. So to find, I have both of those, so I can plug those in, 500 over square root of X minus 0.8X. So to find the profit function, P of X, I need to take the antiderivative of my marginal profit. And I am in terms of X, so dx. So before I can find this antiderivative, I need to rewrite that first part. So I need to rewrite it. Dividing by the square root of X becomes X to the negative 1/2. We saw that in one of the previous videos. The second term doesn't need to be changed. So when I find the antiderivative, negative 1/2 plus 1 is a positive 1/2. I divide by this new power. Minus 0.8x, 1 plus 1 is 2. I divide by this new power, plus c. So P of x is equal to, instead of dividing by 1/2, I'm going to multiply by 2 over 1. So it will become 1,000. I'm going to rewrite it as the square root of x minus 0.8 divided by 2 becomes 0.4 x squared plus c. But this is the family of antiderivatives, and I want the particular profit. I need to find c. So it gives me a way to find c by giving me a point. So what I'm going to do is I'm going to plug in this point. I'm going to find c, and then I'll be able to plug in 20. So I have 3,000 is equal to 1,000 square root of 9 minus 0.4. 9 squared is 81 plus c. So 3,000 is equal to 1,000, square root of 9 is 3, so 3 times 1,000 is 3,000, minus, and then I have 0.4 times 81. So that's going to give me 32.4 plus c. The 3,000s are actually going to cancel each other out, so I have 0 equals to negative 32.4 plus c. So c is equal to 32.4. So now I have my profit function. P of x is equal to 1,000 square root of x minus 0.4x squared plus 32.4. And now I can finally plug in 20. So P of 20 is going to be 1,000 square root of 20 minus 0.420 squared plus 32.4. And because it's money, we're going to round to the nearest 100ths. So we have this 1,000 times the square root of 20 minus 0.420 squared, which is going to be 400, plus a positive 32.4. So in terms of money, that will give us 44,344 and 54 cents. So if we go through the process again, I find the profit function by doing marginal revenue minus marginal cost and then taking the antiderivative. I find my particular C, I plug in 120. I plug in 20. Let's do a very similar type of problem. In a certain section of the country, it is estimated that T weeks from now, so T is measured in weeks, the price of turkey will be increasing at the rate, and then it gives you the rate of the price function. And what's important to notice here is how it's measured. So cents per kilogram per week. If a turkey currently costs $2 per kilogram, what will it cost 5 weeks from now? So it gives you the rate of the price, so the derivative of the price. It tells you that currently, so currently means T equals 0 because it's right now. So the price when T is 0 is $2. But what you need to be careful of is that the price is measured in cents. So you need to rewrite the dollars in cents. So $2 is 200 cents, 200 pennies. And then it's asking you, what is it 5 weeks from now? So T is in weeks, the price is in cents, and I'm again putting the 0 and the 5 in the regular P because it's telling me the price, not the rate of the price. So just like in the previous question, my first go-to is that I need to find the price function. So P of T is going to be the antiderivative of the rate of the price. Now, before I can begin my antiderivative, I need to change T to the 1/2 instead of the square root of T. The 4 doesn't need anything. And now I can begin. And I wrote dt, not dx, because I'm in t's. Pay attention to your variables. So 1/2 plus 1 is 3/2. I divide by this new power, plus 4 times t plus c. So instead of dividing by 3/2, I will multiply by 2/3. 6t to the 3/2 plus 4t plus c. This 3 cancels out with the 3 and the 6 and leaves me with a 2. So I have that P of t is equal to 4t to the 3/2 plus 4t plus c. And I can rewrite it into a square root one last time. So it's going to give me 4 square root of t cubed plus 4t plus c. Now this is the family of antiderivative. I need the particular one, so I need to find c. It gives me a way because it gives me a point. So the price is 200 when t is 0. So this will be 4 times 0 plus 4 times 0 plus c. So c is equal to 200. So I'm going to rewrite my price function. So my price function is going to be P of t is equal to 4 square root of t cubed plus 4t plus 200. And now you can plug in. So remember what the question was asking you, is asking you 5 weeks from now. So P of 5 is equal to 4 square root of 5 cubed plus 4 times 5 plus 200. So the process is the same, but of course the wording is a little bit different, which can of course, really the wording of a word problem, it can be the tricky part, putting the words into math symbols. So we get here 264.7. So we're actually going to round out to 265. But remember, this was cents. So I need to put it back into dollars. So this will be $2.65. And here's my final answer. I think one of the trickiest part about this question is the cents part, because that could be really overlooked, which would make sense. So anytime you have a word problem, pay attention to your units of measure.